Welcome to the future of space exploration, a future that's no longer dominated by gigantic billion-dollar satellites, but by something much smaller, much more accessible, and yet incredibly powerful. Today, we're diving into the world of CubeSats, the tiny satellites that are revolutionizing space technology. If you've ever wondered what CubeSats are, how they work, or why they're so important, stick around. This is CubeSats 101. Let's start with the basics. So, what exactly is a CubeSat? As the name suggests, these satellites are literally cubes. The standard CubeSat measures 10 x 10 x 10 centimeters, a compact little box that weighs just about 1.3 kilograms or around 3 pounds. These units are often referred to as 1U CubeSats, with larger variants like 2U or 3U stacking multiple units together to form a bigger satellite. But don't let their size fool you. CubeSats might be small, but they're packed with cutting-edge technology that can perform incredibly sophisticated tasks. But why are CubeSats so significant? The traditional view of space exploration involved massive, expensive satellites that took years to build and launch, often costing hundreds of millions of dollars. In contrast, CubeSats are cheap, well, cheap for space. Depending on the mission, the cost of building and launching a CubeSat can range anywhere from $50,000 to $500,000. That's still a lot of money, but compared to a typical satellite, which can run into the hundreds of millions, it's practically pocket change. And that price difference has opened the door for a whole new group of players in the space industry. Now, what makes CubeSats even more attractive is their accessibility. Universities, research institutions, and even small companies, places that previously couldn't even dream of launching a satellite, are now able to get their own experiments into orbit. Educational institutions are using CubeSats as hands-on teaching tools for the next generation of engineers and scientists. Imagine being a college student working on a satellite that actually gets launched into space. Pretty amazing, right? But there's another key factor to the rise of CubeSats: ride sharing. Think of CubeSats like hitchhikers. They don't need their own dedicated rocket launch. Instead, they ride along as secondary payloads on rockets that are already heading into space for bigger missions. SpaceX, for example, frequently launches rockets with several CubeSats tucked away alongside larger satellites or cargo. This reduces launch costs and makes space accessible to more people and organizations than ever before. So what can CubeSats actually do? You might be thinking, sure, they're small and cheap, but are they useful? The answer is an emphatic yes. CubeSats have been used for a variety of missions, from Earth observation and scientific research to communications and even technology demonstration. Some CubeSats are equipped with cameras, allowing them to take pictures of Earth or other celestial objects. Others carry sensors that monitor the atmosphere, measure radiation, or even study cosmic phenomena. And because they're small and inexpensive, CubeSats are perfect for testing out new technologies. If a mission fails, well, the loss isn't nearly as devastating as losing a multi-million-dollar satellite. One of the most fascinating things about CubeSats is how quickly they've evolved. The first CubeSat was launched back in 2003, and at that time it was mostly a novelty, a tool for academic research. Fast forward to today, and CubeSats have become indispensable in space exploration. Companies are even developing entire constellations of CubeSats that work together to provide services like global internet coverage or real-time Earth monitoring. Projects like Planet Labs, which uses a fleet of CubeSats to photograph the Earth daily, have changed the way we think about what's possible in space. However, CubeSats aren't without limitations. Their small size means they don't have the power or lifespan of larger traditional satellites. Most CubeSats operate for a few months to a few years before they fall out of orbit and burn up in the Earth's atmosphere. Additionally, their limited space for instruments means that, while they can perform certain tasks well, they aren't equipped for the more complex missions that larger satellites handle. For example, you won't see a CubeSat mapping the surface of Mars or providing GPS services anytime soon. But that doesn't mean CubeSats are a niche product. In fact, They complement larger satellites perfectly. While bigger satellites can provide long-term global services, CubeSats can fill in gaps with more specialized, short-term missions. They're particularly useful for low Earth orbit missions, where proximity to the planet allows them to collect data, test technologies, or perform observations that would be much more costly or difficult for a larger satellite. One area where CubeSats are making a huge impact is in disaster monitoring and environmental science. Imagine a constellation of CubeSats working together, capturing real-time data on wildfires, hurricanes, or deforestation. That kind of system could provide immediate information to governments and organizations, helping them respond faster to disasters or track long-term environmental changes. And again, because CubeSats are so cost-effective, it's feasible to deploy many of them at once for comprehensive coverage. Now let's talk about the future of CubeSats. As technology continues to advance, we're seeing CubeSats take on more ambitious roles. New propulsion systems are being developed that would allow CubeSats to change their orbits or extend their operational lives. Solar sails and ion thrusters, technologies once reserved for large, expensive spacecraft, are now being adapted for CubeSats. This could open up entirely new missions, including interplanetary exploration. Yes, you heard that right. Interplanetary CubeSats. In fact, NASA is already working on missions that use CubeSats to explore the Moon and even Mars. One example is the Mars Cube 1 mission, which sent two CubeSats to follow the InSight lander to Mars. These small satellites were responsible for relaying data back to Earth, proving that even in deep space, CubeSats have a role to play. To sum it all up, CubeSats may be small, but their impact on space exploration has been huge. By making space more affordable and accessible, CubeSats have democratized space in ways we never could have imagined. From academic research to commercial applications, they are transforming how we use and understand space. Sure, they have limitations, but their flexibility, low cost, and potential for rapid innovation make them an essential tool in the future of space technology. So next time you hear about a rocket launch, don't just think about the big, expensive satellites riding along. Somewhere inside that rocket, there's probably a CubeSat, quietly helping to change the future of space exploration. Thanks for watching today's video on CubeSats 101. If you enjoyed this video, please like, share, and subscribe for more content on the fascinating world of space technology.